start the new lectures or new topic, that is the solid state chemistry. Okay. So in the solid state chemistry, we have to cover the points like the some basic or introductory part of the solid state chemistry, like the types of solids, amorphous or crystalline solids. Then the basic terminologies, for example, crystal lattice or space lattice, lattice site, lattice planes, unit cells. Then again, we considered the laws of crystallography, then law of constancy of interfacial angles, law of rational indices, or law of crystal symmetry. Then again, we considered as a law of crystal symmetry, like plane of symmetry, axis of symmetry, and center of symmetry. Again, we have to cover in this topic, that is Weiss indices and Miller indices. Then cubic lattice and types of cubic lattice. This is the FCC, simple cubic lattice, FCC and BCC. So body center cubic and face center cubic. Then again, we covered the diffraction of X-rays and uh, derivations for the Bragg's equations. So these are the points. Again, we consider the determinations of crystal structure by Bragg's methods, then determination of crystal structure of NaCl and KCl with the basis of Bragg equations, and characteristics of NaCl and KCl structures. So their structures, NaCl and KCl structure, can be characterized with the help of the Bragg's equations and the numerical problems. So these are the points we have to cover, proposed to cover in this topic, right? Uh, Let me start the lectures with the simple basic introductory part of the solid state chemistry, right? Uh, we know that the matter is existing in the natures. It is in different states like solid, liquid, and gaseous. Some other matters present in other state also. That is, we know that the colloidal state also, and plasma states. Nowadays, the research is going on for the Bose-Einstein particles in France. Okay, so that one is the one of the particles, but we not considered all this remaining two or three. So we considered only the mainly three matters, state of matters, like solid, liquid, and gases, right? So in this, out of these three, the gases have neither a definite shape nor definite volume. So it means that the gaseous molecules have very less interactions between the two gaseous molecules, and it's free to move anywhere in the any directions. But this not happen in the case of the liquids. Liquids having a definite volume, but it does not having a definite shape. But the molecules of these liquids, two molecules of liquids, it's interacts little bit interacts to each other. And uh, in case of solid, the solid having both shape, definite shape, and definite volume. Solids have, because the solids are it is rigid, and the volume of the solid changes with very slightly with the temperature and pressures. So these are the conditions. This solid can be changed their uh, volume and shape with the temperature, higher temperature, lower temperature, higher pressure, and the lower pressure. These are the conditions of the uh, reaction conditions and that time. So at that conditions, they have changed their shape and volume also. So in solid, the force of attraction between the two solid molecules is very high uh, than that of the liquid and the gaseous, right? So the volume occupied by this definite amount of this substance is gaseous state is very large approximately than that in case of this gaseous state, but in case of the solid, which is not the happened, right? So the volume is occupied by the gas molecule is 1,000 times greater than that of the solid and the liquids. Okay, so this is all the basic informations about the solids, liquid, and gases. That is the state of matters. So solids are of the substance which having a definite volume and a definite shape. So these solids are of two types. One is the amorphous solids, and second one is the crystalline solids. So this crystalline solids having a regular arrangement of atoms, ions, or molecules throughout of the crystals. For example, your NaCl or crystals. So here is the regular arrangement of atoms. Each an atoms, it's regular arrangement. Here, this is the atoms. It is regularly arranged, this one by one, and the second layer it is regularly arranged one by one. So this is the regular arrangement in atoms or the ions or the molecules in the crystals. So this is whole, it is the crystals, right? And each and every atoms it's arranged in regular manners. Okay. But in case of these amorphous solids or the amorphous crystals or the amorphous solids, we can say that also it is called as the it is a state of between solid and liquid. So it is also called as a supercooled solids. So these amorphous solids having a regular arrangement of atoms, ions, or molecules is over a short range. It is when it is not the amorphous solids do not no definite geometrical shape, because there is a no regular arrangement of atoms or ions or the molecules. So this regularity of this internal structure of it's partially, and as compared to the crystalline solids सारखं याच्यामध्ये arrangement नाहीये. So see here, this the atoms it is present in the at any there is a volume, but there is no any kind of regularity. Okay, but in here the this arrangement it is a regular manner, right? So first stage, second stage, third stage, like this. But here is not the case. The no definite geometricals or the no definite regular arrangement of atoms or ions or the molecules. So this amorphous solid it is called as the supercooled solid because it is the state of between the solid and liquids. So the physical properties of this amorphous solid, that is mechanical, thermal, or the any kind of these electrical properties, are all the direction. It is the same in all the directions. सगळ्या direction it is same असणार आहे. But in case of this crystalline solid, this is not happen. So this thermal, electrical, and the uh, mechanical properties are different in different directions. Because, for example, this is the NaCl and this is the KCl. It is different thermal, mechanical, and this electrical properties in different directions, right? So this is all about the we call it is the properties, different properties or these different directions. But he in amorphous solid this is not happen, right? The again NaCl and CuSO4. CuSO4 it is an examples of this one. CuSO4, ZnS, zinc sulfate, zinc sulfide, copper sulfate, zinc sulfide. Here glass and rubber it is an examples of your amorphous solid. Amorphous solids examples म्हणजे glass, rubbers, and plastics like this. This is also is then the examples of this. Now the characteristics of this ionic solids, right? The ionic solid is it is a crystalline nature. This ionic solids, this hardness of these ionic solids had the hard and brittles. So these are the easily broken when the stress is applied on them. Melting and boiling point is okay. Melting point of this crystalline solid is having a sharp melting point. But in case of the amorphous solids, melting point it is not a sharp. It is not a sharp melting point for the amorphous solids. Again, one of the properties in case of amorphous solid, it is the solid, it is isotropic in nature. Isotropic. Okay, isotropic. But the crystalline solid, it is anisotropic. Anisotropic in nature. Isotropic nature means the properties like mechanical, thermal, and electrical properties is not the it is the same in all the directions. So it is isotropic. Isotropic. Okay. म्हणजे ट्रॉपिक मीन्स रिजन आणि आयसो मीन्स सेम. सो सगळ्याच रिजन्सला ती सारखीच प्रॉपर्टी असते. ट्रॉपिक मीन्स रिजन आणि अनआयसो मीन्स इट इज नॉट लाईक दॅट, राईट. So it is not the same. It is different in different direction, different regions. So this is the one of the comparative study of amorphous and the crystalline solid, right? So these are the crystalline solid. Also, it is called as the ionic solids. So it is the solubility of ionic solids are soluble in polar solvents, and the conductivity in solid state ionic solids are insulator, while in case of this state these are good conductors of electricity. So this is the characteristics of your crystalline solid or the crystalline nature, that is the ionic solids are crystalline in nature. This is an examples of your crystalline solids. Now the classification of crystalline solids are classified into these four types. This one, right? Crystalline solids are classified into four types. There's intermolecular solids, covalent network, and metallic solids, and one is the ionic solids. So this is the four types. This is not included in your syllabus, so we does not go into details of this one. Okay. The crystals. This is the important part in your syllabus. That is crystals. What do you mean by the crystals? Crystals means what? A crystals is a solid which is composed of particles, that is atoms, ions, or the molecules. So this is the uh, arranged in an orderly repetitive way. So that is called as the crystals. Crystals कशाला म्हणायचं आहे तर crystals अशी अरेंजमेंट कशाची, atoms, ions or the molecules. हे जे पार्टिकल्स आहे प्रेझेंट त्या मॉलिक्युल्स मध्ये किंवा त्या क्रिस्टल्स मध्ये, त्या क्रिस्टल्स मध्ये जर atoms, ions आणि molecules हे जे पार्टिकल्स असतील ते जे आहे आणि हे ऑर्डरली अरेंज आहे रिपीटेड वे, सो दॅट इज कॉल्ड ॲज द क्रिस्टल्स. अशाला आपण काय म्हणायचंय, क्रिस्टल्स. For example, if you called crystals, called it is, this is the arrangement, this one is the arrangement of crystals. This is the particles which is repeatedly arranged like this, like this. Okay, so this is the uh, regularly and the repetitive arrangement of each and every ions, atoms or the molecules, which is called as the crystals. Asha arrangement च्या याला आपण काय म्हणतोय, crystals. So this is the solid. Crystals means a solid which composed of the particles is arranged in orderly manner, right? So are they repetitive manners? Now again we consider as the law of crystallography. Law of crystallography. So before that, we just understand the lattice or the crystals, crystal lattice or the space lattice, lattice sites and lattice planes in the unit cell. So we see in the next, but before that we see the law of crystallography. So the first terminology, that is the space lattice or also called as the crystal lattice. Space lattice ला काय म्हणायचं आहे, crystal lattice or the space lattice. So lattice lattice म्हणजे काय तर systematic and symmetrical arrangement of points or the particles in a space. जसं आपण crystals म्हणजेच lattice, crystal म्हणजेच lattice. Systematic arrangement किंवा systematic manner of arrangement of particles or points. Systematic arrangement particles of points, याला आपण particles म्हणू शकतो किंवा points म्हणू शकतो. So this systematic arrangement of particles or atoms or molecules in a space, it is called as the, this is the lattice. This is called as the lattice. त्याला आपण lattice म्हणतो. So in a crystals, आता या लॅटिस मध्ये याला आपण क्रिस्टल्स किंवा लॅटिस. So we called it is crystals or lattice. So this is the crystals or lattice. The atoms, ions or the molecules which this are not oriented at random but are packed together with the greater order or regularity in the three-dimensional patterns. हे आपण तिथं बघितलं ह्या थ्री डायमेन्शनल स्पेस मध्ये थ्री डायमेन्शनल पॅटर्न्स मध्ये रिपीटेडली अरेंजमेंट अँड द रेग्युलर मॅनरली ते अरेंज होते त्याला आपण काय म्हणतोय क्रिस्टल लॅटिस किंवा lattice or the crystals. Okay, so the space lattice or the crystal lattice may be defined as and the points showing how the atoms, ions, or the molecules are arranged at different sites in the three-dimensional space or this space. So this is the called as the space lattice. त्याला आपण space lattice म्हणतो. So in that space lattice, each and every points represent ions, atoms, or the molecule. For example, this one. आता हा एक point आहे किंवा असं असेल. तर this is the point. It is represent atoms, ions, or the molecules. So repeated unit like this one, right? Repeated unit like this. So this is the repeated unit, and this is called as the crystal lattice or the space lattice. Each and every points representing atoms, ions, or the molecules. प्रत्येक points ला आपण काय consider करतोय atoms, ions, or the molecules, and this is the one unit. This is the second unit. So this arrangement it is repeatedly. So this arrangement of these atoms, ions, or molecules in the three-dimensional space it is called as the crystals, and this is the showing the arrangement at different sites at different three-dimensional space. So each points represent ions or ion molecules or atoms, or it is called as the group of these constituents. The space lattice is three-dimensional arrangement of identical points is in a space or this three-dimensional space. An important characteristics of the space lattice is that each and every representing points, these atoms or ions or the molecules, which is same surrounding as the any other points representing the same atoms or ions or the molecules. So this space lattice is also called as the crystal lattice. याची सर्वात महत्वाची आणि इम्पॉर्टंट कॅरेक्टरिस्टिक्स काय आहे स्पेस लॅटिस मध्ये की इथे जो पॉइंट आहे किंवा इथे जो पॉइंट आहे याच्या या साइडला या साइडला या साइडला या साइडला सेम पॉइंट्स असतात किंवा सेम ॲटम्स किंवा आयन्स असतात. सो इन दिस वे here also the same atoms or ions are this. So this is the very important points or important characteristics of the space lattice. Then the second terminology, basic terminology in the solid state chemistry is that the lattice sites. Lattice site. What is mean by the lattice sites? Lattice site कशाला साइट म्हणजे काय तर ती जागा किंवा त्या साइट्स आपण त्याला काय म्हणू शकतो की इट इज द बाजू त्याला आपण काय म्हणायचं बाजू म्हणायचं किंवा ती जागा म्हणायची आहे. सो लॅटिस साइट्स मीन्स इट इज द सिंपल पोझिशन occupied by points or the particles or the atoms in the crystal lattice is called as the lattice site or the lattice point. This one. This is the lattice site and this is the point which is occupied by your atoms. This is the site which is occupied by your atom. These 2 points it is called as the lattice site. This is called as the lattice site. Right? And these crystals it is bound by the external faces which are generally planar, and these are called as the faces of crystals. This one. So this is the point and this is the points. This is the lattice site and this lattice site it is bound to each other, and therefore this is called as the faces of lattice. This side it is called as the faces of lattice or the faces of crystals. So this angle between these two intersecting faces is called as the interfacial angle. So now the angle between this is the point, this is the point, this is the point which is bound by this position, this position, this position. And whenever the angle is made by the binding of these two atoms or those 2 points, where the points it is called as the site or this site is bound by something like this. So whenever the made the angle, so that angle it is called as the interfacial angle. This angle it is called as the interfacial angle. So this angle it is called as the interfacial angle. For example, the crystals of sodium chloride. If you take an examples of the crystal of sodium, जर सोडियम क्लोराईडचा तुम्ही क्रिस्टल घेतलाय तर तो परफेक्टली अरेंज असतोय, म्हणजे सोडियम मेटल्स, सोडियम आयन्स अँड क्लोराईड आयन्स हे परफेक्टली असते. फॉर एक्झाम्पल इथे जर सोडियम प्लस असेल, सो हिअर, हिअर अँड हिअर, सो इच अँड एव्हरी टाइम हिअर, इच अँड एव्हरी पोझिशन और एव्हरी साईट, त्याला आपण साईट म्हणतोय. दिस इज कॉल्ड ॲज द साईट. सो एव्हरी sodium, each and every sodium ions, it is bound by this chlorine ions, and each and every chlorine ions, it is bound by the sodium ions, it is bound by the sodium ions here. आता तुम्हाला लक्षात येईल की प्रत्येक सोडियम आयन्स हा क्लोरीनने बाउंड केलेला आहे आणि प्रत्येक क्लोरीन आयन्स हा सोडियम आयन्सनी बाउंड केलेला आहे. So in this way, this is the units which is repeated in a regular manner in the crystals. So this is the sodium crystal, sodium chloride crystals. It is a repeated and regular manner arrangement of crystals. So these positions of each and every sodium, it is represented by the points, and it is three-dimensional space or the network. ह्या three-dimensional space आणि network मध्ये तो काय असतोय, present असतोय. So this is the points of each sodium atoms. It is surrounded by the chlorine ions, and each chlorine ion is surrounded by the sodium ions in a space, or is three-dimensional space, or this is the network of your the points or the atoms, ions, or the molecules. Thus the space lattice of sodium chloride, it is made up of the interlocking of sodium and chlorine lattices. This is the lattices and it is interlocking. याला जर आपण असं जॉईन केलं तर इथे काय असणार आहे, here is the also Cl ions. याला आपण अशा पद्धतीने जॉईन करूया तर हा सोडियमचा एक क्रिस्टल्स तयार होईल. दिस इज द सोडियम क्लोराइडचा क्रिस्टल्स तयार होईल. सो इन दिस वे दिस कॅन बी जॉईन लाईक दिस. अशा पद्धतीने आपण याला जॉईन करणार, राईट, दिस वे. So this is the three-dimensional space of, or the crystals of sodium chlorides. Now the third basic and important terminology in the solid state chemistry, that is the lattice plane. हे एकदा का तुम्हाला क्रिस्टल म्हणजे काय, लॅटिस म्हणजे काय, क्रिस्टल लॅटिस म्हणजे काय, स्पेस लॅटिस म्हणजे काय, देन दिस लॅटिस साइट अँड लॅटिस प्लेन हे एकदा का समजलं तर मग तुम्हाला सॉलिड स्टेट केमिस्ट्री समजायला काही कठीण नाही. So just keep in your mind and very focus, very concentratedly listen this terminologies, right? Then after that we just move towards the law of crystallography. So next and the last basic basic terminology which is always used in the solid state chemistry, that is lattice planes, lattice plane. So the point lattice plane कशाला म्हणायचं, the point in a space lattice can be arranged in a number of parallels or equidistant planes which are called as a lattice planes. अशा प्लेन्सला फॉर एक्झाम्पल आता इथे एक पॉइंट आहे, इथे एक पॉइंट आहे, इथे एक पॉइंट आहे, हा एक पॉइंट आहे, हा एक पॉइंट, हे सगळे जर जॉईन केले आणि अशा पद्धतीने जर इथे एक प्लेन तयार होत असेल, see this interlocking the points or interlocking this plane, and this plane can be equidistance. आता इथे पण एक प्लेन आहे, हा एक प्लेन, इथे पण एक प्लेन आहे, हा एक प्लेन. So this is the plane, each plane it is called as present at the same distance, हे same distance वरती present आहे. So the points in a space lattice can be arranged in a number of parallels or equidistant planes, that called as the lattice plane, that is called as the lattice plane. So the external faces of these crystals are parallel to these planes, and the most common things is that the faces of crystals are those corresponding to planes containing the large number of points. For example, आता तुम्हाला असं लक्षात येईल, दिस इज वन ऍक्सिस, इज टू डायमेन्शनल मध्ये आपण बघूया की एक्स ऍक्सिस आणि वाय ऍक्सिस वर असेल, हे पॉइंट्स आहे लॅटिसचे. दिस इज द पॉइंट्स विच इज द प्रेझेंट, दिस इज द पॉइंट्स, दिस इज द प्रेझेंट. सो हे पॉइंट्स जॉईन झाले, हा एक प्लेन, हा एक प्लेन, हा एक. these are the planes present in equidistance. So this is the space lattice planes or something like this. काहीतरी अशा पद्धतीने असू शकते. This is the points, this is the points, or this is the points. So this is called as the plane, and which is present at the equidistance. Again, the type of this one, this one, this one, this अशा पद्धतीने पण planes असू शकतात. So planes is the planes like this. This is the planes like this. This one, right? This is the plane. So each and every plane, it is present in the equidistance. Each and every plane, it is present in the equidistance. So this is called as the lattice plane. So all these planes, it is passing through the points, the different points. It's a planes, lattice planes. It is passing through the different points present, or different points means different sides of the lattices. Lattice साइडच्या वेगवेगळ्या साइड्स मधून ते काय होतात पास होतात. So this is called as the lattice plane. The last definitions of the terminology used in the solid state, that is a unit cell, and it is very important. A unit cell is smallest structural units in the space lattice. This is called as the unit cell. हा एकच असेल तर याला unit cell म्हणायचं. So आणि this unit cell, it is the repeated again and again in the three-dimensional. So this basic unit, it is called as the unit cell. This is called as the unit cell, and each unit cell is repeatedly arranged in the regular manner. So this, which when repeated in three-dimensional space, result in a crystals. हे जर असे एकत्र केले सगळे युनिट्स तर त्याला आपण क्रिस्टल्स म्हणतो. So the unit cell is the smallest and sample that represent the entire picture of the crystal. So the crystals may consist of the infinite number of unit cells. It means that this is the crystals, it is the considered as the infinite number of the unit cell. So this means that the fundamental elementary patterns of the crystal is known as the unit cell. क्रिस्टलच्या फंडामेंटल आणि एलिमेंटरी पॅटर्न्सला आपण काय म्हणतोय, युनिट सेल असं म्हणतो. So this space lattice or unit cell can be linked with the wallpaper on which the single pattern is continuously repeated. So it means that the unit cell is repeating definite patterns or repeating again and again in the three-dimensional space, and the space lattice of the crystal, it is in 3 dimensions. So the unit cell is the smallest sample, and that represents the picture of entire crystals or the entire space lattice, which shows that the properties of crystals in all the elements of the symmetry of the crystals. जसं की आता आपण जर 3-dimensional स्पेस घेतली तर हे असं x एक्सिस, y एक्सिस आणि z एक्सिस, इथे एक युनिट आहे. फॉर एक्झाम्पल आपण असं कन्सिडर करूया, this is the one unit, this is the second unit, this is the third unit. So repeatedly, this is the units which will be considered as like this. अशा पद्धतीने हा असं. So त्या 3-dimensional स्पेस मध्ये तो अशा पद्धतीने तुम्हाला काय दिसतोय. This is the units. This is again the unit. This is the 3-dimensional space. आता तुम्हाला इथे लक्षात येणार नाही. Okay. So in this way we can say that this is the basic units or the basic sample of this pattern. It is called as the unit cell. It is called as the units, and repeated again and again. It is made of the entire picture, that is the crystals. Yeah, total आपण काय म्हणतो, crystals or the crystal lattice. So it means that the points are present, not lines which constitute the space lattice. These lines joining by the points, that is imaginary points. आता हे जे आपण जॉइन केलेलं आहे हे इमॅजिनरी जॉइनिंग आहे. This is not exactly, it is an imaginary joining. So is draw the simple 3 axes which is relative to the position of the points can be, it is described. So this is all about the lattice, crystal lattice, space lattice, lattice sides or the lattice planes and the unit cells. So this is all about the crystals or the basic terminology which is used in the crystallography or the solid state chemistry. So law of crystallography, it is a simple branch of science which deals with the geometrical properties and structure of crystals and the crystalline substances. Now, crystallography is based on three fundamental laws. तीन फंडामेंटल लॉज वरती क्रिस्टलोग्राफी डिपेंड आहे. एक लॉ ऑफ कॉन्स्टन्सी ऑफ इंटरफेशियल अँगल, सेकंड वन इज लॉ ऑफ रॅशनॅलिटी ऑफ द इंडायसेस अँड थर्ड वन इज द लॉ ऑफ सिमेट्री. क्रिस्टलोग्राफी याच्यामध्ये आपण कशाचा स्टडी करतो, जॉमेट्रिकल प्रॉपर्टीज अँड स्ट्रक्चर ऑफ क्रिस्टल्स किंवा क्रिस्टलाइन सबस्टन्सेस, याच्यामध्ये आपण जॉमेट्रिकल प्रॉपर्टीज त्याच्या किंवा स्ट्रक्चर याचा आपण स्टडी करतोय. आणि कुठले लॉज आहे तर तीन लॉज आहे. एक आहे लॉ ऑफ कॉन्स्टन्सी ऑफ इंटरफेशियल अँगल. इंटरफेशियल अँगल ही कॉन्स्टन्सी तुम्हाला दाखवते, तो एक लॉ. सेकंड लॉ आहे की रॅशनॅलिटी ऑफ इंडायसेस, दिस इज one of the law, and third one is the law of symmetry. These are the three laws of crystallography. Now this law of crystallography, then we understand this law is given by the steno. हा जो लॉ आहे हा आपल्याला स्टेनोने दिलेला आहे. Then this